Hello guys and welcome back to Chemistry Rules. Today we're going to be talking about the types of chemical compounds. We're going to be talking about two major types of compounds. Basically, the covalent compounds and the ionic compounds. So, we'll learn what's the difference between those two and how do we know if a compound or a molecule is ionic or if it is covalent or so. Okay, let's start. So first is covalent compounds. Covalent compounds, simply put, covalent compounds are compounds that have covalent bonds. Basically, or in other words, these are compounds that share electrons. The compound on the right, methane, is a good example of a covalent compound. Carbon and the hydrogens share electrons to fill their outermost shell. So as you can see here guys, in the left part of the screen, we have the methane, CH4. You can see at the edges of the carbon, at the four directions, the west, east, north, and south, is a hydrogen atom. Now, the hydrogen atom has one valence electron. Each hydrogen atom has one, and the carbon has four valence electrons. Now, the carbon wants to have a full shell, so needs four more electrons to fill that shell or to fill the 8 electrons. Okay, and hydrogen needs one more to get two to be stable, so they share their electrons. Other examples of covalent compounds include water, of course. So oxygen has 6 valence electrons, and each hydrogen has one, so they share electrons. So both hydrogens will have 2 valence electrons now, and the oxygen will have 8. And then the next example is ammonia. Nitrogen has 5 valence electrons. Hydrogen, of course, has 1 valence electrons. Valence electron, I mean. Sorry. Now, nitrogen needs 3 more electrons, so and the hydrogen needs one. So, as you can see here in the ammonia, the molecular structure of ammonia, we have 3 hydrogens, so that nitrogen will have a complete or full shell of 8 electrons, and all of the hydrogens here have 2. And the next, of course, is hydrogen itself, the hydrogen molecule. Both hydrogen atoms need one more valence electron to be stable or to have a full shell. So they're going to bond with each other so that both have a full shell. Now let's move to the next slide. Sorry. Now, which atoms form covalent compounds? Okay, let's see. So typically, nonmetals form covalent bonds with other nonmetals. The reason for this is because none of the atoms are strong enough to fully take or give electrons. So, it's because their electronegativities are not really that far from each other. So, the other can't fully take and the other can fully give electrons. So, methane here is an example of covalent compound. So, the type of bond is dependent on the difference of the electronegativities of the two atoms. So we have here from 0 to 0.39 is nonpolar covalent. From 0.4 to 0.89 is moderately polar covalent. From 0.9 to 1.69 is very polar covalent, and 1.7 or greater is ionic. So in the picture here in the left, on the below the bond type chart, we have some of the elements and their electronegativities. Sorry for that. Now let's move on to the next one. So the next one is ionic compounds. An ionic compound is a chemical compound composed of ions held together by electrostatic forces termed ionic bonding. The compound is neutral overall but consists of positively charged ions called cations and negatively charged ions called anions. Now, again, as we saw earlier in the electronegativity chart there, so in the band type chart, if the differences between the electronegativities of the two atoms is 1.7 or greater, it means that the bond or the compound itself is ionic. So let's go back here. So it means that the difference between these two atoms, the difference between their electronegativities is so high that the other wants to give its electron to get a full shell. The other wants really wants to gain an electron so that it can also get a full shell. Okay, let's move on to the next. So here again, we said earlier, then the next is polar compounds. So a polar compound is a compound made up of molecules joined by asymmetrical polar bonds. Polar compounds show polarity, which is a feature characterized by having two opposing charges or poles. So, unlike ionic bonds, unlike the difference between polar compounds and ionic compounds and covalent compounds, in ionic compounds, the other atom is very electronegative. The other atom is very electro how do I say this is the differences between their electronegativities are very high. Okay, now covalent compounds, their electronegativities are not far from each other. Okay, so if the differences between the electronegativities are not far from each other, then the answer would be close to zero. Okay, now in polar compounds we see this, so it means polar compounds are between covalent compounds and pure covalent compounds and ionic compounds. It means that one part of the atom, one part of the molecule is partially positive and the other part of the molecule is partially negative. So that's how we get a polar compound. So we saw here a compound made up of molecules joined by asymmetrical polar bonds. So we saw asymmetrical. What does that mean? So H2O is asymmetrical, unlike carbon dioxide. Carbon dioxide. Wait. Let me draw carbon dioxide. Wait, let me draw it here. So wait, how do I draw? So sorry for that. So carbon dioxide, we have a C, carbon in the middle, and then we have two oxygens double bonded to the carbon. So because of the double bonds, the molecular geometry of carbon dioxide is linear, so it is symmetrical. So the partially negative charges, cancel each other because they are symmetrical. Okay, now the next one we're going to talk about is the electronegativity again. So the electronegativity of an element increases from the lower left side of the periodic table up to the upper right side of the periodic table. So sorry for this upper left, just a typographical mistake. And then next, Halides are the most electronegative elements. It's because they only need one more electron to fill their shell. Okay? We understand that. So you see there, fluorine. Fluorine is the most electronegative atom element in the periodic table. The least electronegative element is cesium, the lower left side. So electronegativity increases going to the right, going up. Okay? And we also know that these metals in the um most in the left side of the periodic table is the least electronegative elements, or are the least electronegative elements in the periodic table, because they do not want to gain an electron, they even want to lose it. Okay, thank you for listening, guys. Please like the page Chemistry Rules. Please like this video. Please subscribe for more videos in the future about chemistry. Thank you.